Hello guys and welcome back to my YouTube channel. Today we are going to write an algorithm for Newton's forward difference interpolation. So we have the values of x and y and we can write them as a table. For example, x and y, delta square y, etc. Right? And delta raised to the power n y. And these values will be I. For example, 1, 2, 3, the iterations x of 1, x of 2, x of 3, and the values here will be j. For example, 1, 2, 3, etc. So the value of y will be y of 1, 1, y of 2, 1, y of 3, 1, and delta y will be y of 2, 1, this minus 1, 1, 3, 1 minus 2, 1, etc. etc. Right? Therefore, we can write first to start the algorithm, then input n being this, the number of interpolations that we have to apply, and xg. Then we have to put for I is equal to 1 to n. For I, all the values of I from 1 till n, that is all the values of x and y, that will be taken into account. For I is equals to 1 till n, will be input xi, each value of x will be input, and u is equals to xg, that is current value of h minus x1 upon h. H is the, then this will be iterated for all the values of x. Then h is equals to x of 2 minus x of 1 and u is equals to, then for j is equals to 2, n, we will get now the first value, the interpolated value will be taken, and then the values of x and y will be taken into account. That is, for I is equals to 1 to n of j, these will be taken into account for all the values. Y of I comma j, that is the value of forward difference is equal to y I plus 1 into j I minus 1 minus y j minus 1. The value of y can be given as yg is equals to y of 1 and u1 is equals to 1. For j equals to 1 to n minus 1, the value of u is equal to u1 into u minus j plus 1 upon j, and yg is equal to yg, that is the value of yg from here, plus u1 multiplied by y into 1 comma j plus 1. And we have to print yg, that is all, and then stop. Finding the forward differences using the first and second forward difference using the Newton's forward difference interpolation formula. Therefore, we have the forward interpolation formula as f of x is equals to y naught plus u upon factorial 1 delta y naught plus u into u minus 1 upon factorial 2 delta square y naught plus u into u minus 1 into u minus 2 upon factorial 3 delta cube y naught, etc. etc. Now y dash of u is equals to 0. Y dash is a constant, that will be 0. U will be 0 and delta y naught will be the same, delta y naught plus u into u minus 1 will be u square minus u, which upon differentiating which will be 2u minus 1 upon factorial 2 will be 2 delta square y naught plus u into u minus 1 into u minus 2. This will be, which will be u cube minus 3u square plus 2u, which upon differentiating will get 3u square minus 6u plus 2 upon factorial 3 will be 6 delta cube y naught, etc. etc. We can also rewrite the whole function as f of a plus hu is equals to y naught plus u upon factorial 1 delta y naught plus u into u minus 1 upon factorial 2 delta square y naught plus u into u minus 1 into u minus 2 upon factorial 3 y cube delta y cube naught, etc. etc. Now differentiating this with respect to u, we will get f dash of a plus hu is equals to 1 by h. The value of h will be here. 0 plus delta y naught plus 2u minus 1 upon 2 delta square y naught plus 3u square minus 6u plus 2 upon 6 delta cube y naught plus etc etc. And f double dash of a plus hu will be 1 upon h square. 0, this the value delta y will also be 0. 2u minus 1, this will be 0, but it is delta square y naught plus 6u minus 6 upon 6, which will be u minus 1 delta cube y naught plus etc etc. This is how we get the first and second derivatives of forward difference interpolation formula. To obtain the third derivative, we can also do f of triple dash of a plus hu is equal to 1 upon h cube. 0 plus 0 plus this will also be 0 plus u will be 1 minus 1 will remain the same, 1 into delta cube y naught plus etc etc. Thank you.